let's start with the thing that what is positional and non-positional number system. So in the previous video, we have seen that the numbers which are associated with some kind of positions is known as positional number system, but there are some systems which are not associated with any kind of position. Position does not matter in such systems that are gray and access-3 code. So the non-positional number system is also known as non-weighted number system. In this non-weighted number system, weights are not associated with the positions. Digits are independent of its positions. It is used for the shift position and codes and detecting the errors. Let's take an example. Examples of non-weighted number systems are access-3 code, gray code, etc. So we will start with this positional and non-positional number system in detail. So positional number system is that number system in which positions are associated, just like 8421 code. Here we are associated with the positions. But in the case of non-weighted or non-positional number system, position does not exist. Position does not matter. Let's start with the binary coded decimal. So first of all, what is binary coded decimal number? So BCD numbers are known as binary coded decimal numbers. Okay. Now for the fast calculation and the conversion, binary coded decimal numbers are used. Actually, it is used to display the decimal numbers in the binary form. Okay, and in this the decimal number is written by replacing the decimal digit in integers and fractions with its 4-bit binary equivalent value. The range of BCD numbers are from 0 to 9. 10 is not a BCD number. And the most commonly used BCD code is 8421, where the digits 8421 depicts the weight of different bits in the combination of 4 bits starting from MSB to LSB. The other BCD codes are 4221, 5421, and these codes are weighted binary codes because each position of a number represents a specific weight. See, this is the table. Here you can see the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Why I have taken till 9 only? Because I am dealing with the BCD code and BCD numbers are only from 0 to 9. If someone asks you to represent BCD number into 8421, then how will you move? Now for example, the digit is 0. 8421. 0 is nothing is in combination with 8421. 1 can be written as 0001. Similarly, 5 can be written as a combination of 4 and 1. So you can write it as 0101. Means positions 8421 with the positions, wherever the positions are activate, just put 1. Which positions are not activate, just put 0. For example, 9. 9 is the combination of 8 and 1. So this and this position is activated. So we are writing 1 as per this position and 1 as per last position in between these two zeros. Okay, now the same BCD code using 4221 method. Here also you can write the corresponding digits in BCD code just like 4 number. Because this 4 is activated, so you can simply take 1000. Similarly, if 6 is there, now our preference is because 2 are there. This is also 2 and this is also 2. So we will prefer first one. Okay, always. So it is a combination of 4 and 2. 4 2 is this thing 110. Now you have to write 7. Okay, so we can write the 7 as 4 plus 2 plus 1. So this 7 can be written as 4 plus 2 plus 1, that is 7. So it is the correct answer. Similarly, for 8, It is the combination of 4 plus 2 plus 2. So we will write 1110. Basically, whichsoever the value is activated, just put 1 there, otherwise put 0. For example, the last one, 9. 9 can be made by taking all the values along with. Just like 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 1 is 9. So we have to write 1, 1, 1, 1 as a final number. So this is the case of 4, 2, 2, 1 method. Now come to 5, 4, 2, 1 method. We have to represent our BCD code in 5, 4, 2, 1. For example, 3. 3 can be written as 0, 0, 1, 1 because this 2 and this 1 is 2 plus 1 is 3, so you can write it as 0, 0, 1, 1. Similarly, 4. 4 is 0, 1, 0, 0. 5. It is 1, 0, 0. 6. 6 can be written as, see, there are two things. You can write a 6 as 5 and 1 and combination of 4 and the 2. But we will prefer first one. Okay. So 5 plus 1 is 6. So we will give with 1, 0, 0, 1. Similarly 8, because if you go with 5 plus 4 it is 9. It is a bigger one. We will go with 5 plus 2 plus 1. 5 plus 2 is 7. 7 plus 1 is 8. So it will be 1, 0, 1, 1. Now come to 9. 9 is 5 plus 4. So it is 1, 1, 0, 0. So in such a manner, we can represent BCD numbers in different codes, which are the positional number systems or weighted number system. Just go through this one, then we will move forward. So the easy and efficient conversion in between 8421 numbers and familiar decimal numbers is the main advantage of this BCD code. For example, using 8421, decimal digits can be easily converted. So it is the easy and efficient way to convert a decimal number into a binary number system. Let's take examples. Question is, convert BCD to decimal number system. They have given a number 1001 000. So whenever you have to write the BCD numbers to decimal numbers, means this is a BCD number, we have to write the corresponding decimal numbers. So first of all, we have to make a group of 4 digits or bits. So I can write, now you can write the corresponding value. So it is 1001, it is 9. So 0001, it is 1. So the final answer will be 9, 1. Don't forget to mention the base. The base is decimal, it is 10. Similarly, other question is 0001, 0001. Here also we will make a group of 4 bits. So it is 0001 corresponds to 1. Other 0001 corresponds to 1. So the final answer will be 1, 1 in a decimal number system. So what we have learned in this thing, that how to convert a BCD number to a decimal number, means you will take a BCD number, then you will bifurcate further in 4 bits group. Okay, 1001, 0001 for example. Then you write the corresponding decimal values in the result. This is the conversion of BCD numbers to the decimal numbers. Now the next is how we can add two BCD numbers. Now it has some rules. First of all, add two BCD numbers just like the additions, binary addition. So if the resultant, means whatsoever the final result you are getting is less than equal to 9, we can say it is a valid result. But if it is more than 9, then add 6 to the resultant. If carry is generated, then represent the carry in the 4 bits. So whenever you are adding two BCD numbers by a binary addition, first of all check whether the final number is value more than 9 or less than 9. If it is less than 9, it is a valid result. If it is more than 9, it is not a valid result. So what you will do, if it is not a valid result, you will add 6 to the final value. And if carry is generated, write the carry in 4 bits separately. Let's take an example. Take a first question. First question says 1001 plus 0001. So two BCD numbers are 1001 and 0001. We are adding it. Simple number, you are adding it. So whenever you are adding it, you are getting 1010. When you are taking 8421, it is 10. Rule says if the number is less than 9, it is a valid, otherwise it is an invalid. Because we are getting 10 here, it is an invalid BCD sum. So what you will do, you will add 6. 6 means 0, 1, 1, 0. Simply add 0, 1, 1, 0 here. So it is 0 as such, 1, 1, 0 with this 1 carry, 1, 1, 0 with this 1 carry. Then 1, 1, 0, here carry is there and then 1. So now this 1 is carry. How we can say it is a carry? Because here it is 4-bit number and you are getting the result in 5-bit. So first one is carry. So as per rule, we will represent the carry in 4 bits. Okay, so this is the final answer. Otherwise also you can see it is 1 and it is 0. And question was 9 plus 1, 10. Here answer is 10. So it is the thing. Now take the second question. 0001 plus 01, 01, 11, 01. So whenever we are adding these two numbers, we are getting a valid BCD. Because whatsoever the sum you are getting, you will further bifurcate in 4-bit combination. And it is 6 and 6. So that's why it is a within the limit. So the answer is valid BCD. Okay, simple rule is just add two numbers. If by adding the two numbers, whatsoever the result, bifurcate in 4 bits, and still if its value is more than 9. So what you will say? You will say it is an invalid number. Now what you can do with this invalid number? You will add 6 to this invalid number. After adding 6 to this invalid number, whatsoever the answer you are having, if you are having a carry with this, then represent the carry separately in 4 bits. So this is the final thing. And if it is a number is in between the range 0 to 9, means it is a valid BCD number. So this is all about the BCD addition. Now come to the BCD subtraction. If you remember in the previous videos, we have seen that we can subtract the numbers using r's or r minus 1's complement. So here also we can subtract two numbers using 9's complement or using 10's complement. 9's complement means r minus 1's complement and 10's complement means the rules of r's complement will be followed here. So let's take a first question. Here two questions are there. First part is subtract 888 minus 243 using 9's complement. So the rule says first of all find out the 9's complement of y. For example, I am saying that it is x minus y. Okay, so we are doing it using 9's complement and we are doing it using 10's complement. So when we are using it using 9's complement, the rules of r minus 1 will be followed. That is, find out the 9's complement of y, add to x. If carry is there, add the carry to LSB. If carry is not there, take again the 9's complement of the result and put a negative sign. So let us see what is happening over here. So 9's complement of y, that is 243. So 9's complement of 243 is 999 minus 243. That is 756. Now you will add this 756 to the 888 and check whether carry is there or not. Here it is 3 bit, here it is a 4 bits digits. So you will add this carry to this LSB. So answer will be 645. If the same question is done using the tens complement, you can see that find out the tens complement of y, add 2x. If carry is there, discard the carry. If carry is not there, take again the tens complement of the answer and put a negative sign. So what we will do? We will find out the tens complement of 243. It is 1000 minus 243. It is 757. Now add this 757 to the 888 and you will get 1645. Now we will check whether carry is there or not. Just like in the previous videos, we have seen that how to measure the carry. Carry can be measured by counting the number of digits in the sum and minuend and in the question and in the resultant. If it is matching, then it is no carry. If it is having an extra bit, extra digit in the resultant, it means it is having a carry. So the carry is here, but the rule says, R's complement rule says, if carry is there, then what you will do? You will ignore this carry. Ignore this means discard this carry. We are not worried about this carry. So we are left with only 645. So 645 is the final answer. So whether we are taking the 9's complement or 10's complement, we are getting the same answer, that is 645. That is the actual answer. Because 888 minus 243 should be 645 only. So in this video, we have seen that what is BCD number, how we are adding to BCD numbers, how we are subtracting to BCD numbers, and what is the role of BCD numbers, why we are using the BCD numbers, what is the range of BCD number, what we will do if carry is there, what we do if carry is not there. So this is all about the BCD number system. We will meet you again in the next video. Till that, thank you so much.